Now, we see our number here. If I was going to say this number, I probably wouldn't say 3. I would say something like 10 3s, 5 5s. Computers are the same. Computers run on memory and storage, so at the most it can reduce things, reduce the memory, make things more optimal, the better. So a computer could actually say this, 10 3s, 5 5, something like in a way like this. And you can see this third bullet point actually takes a lot less space than the first bullet point, which means it's optimized, it has the same information. So how does this work in a table? Now we have a table here, and you can see that some of the values are repeated over and over, right? Of course, if we're looking at columnar store, we can think of each column individually. Because we're storing it as columns, everything can be done on each column individually, and this is a big advantage of columnar store. So here we have Bill. Bill repeated 3 times, right? Jane repeated 3 times. So what we can do is every time we get a new value in the column, we just put a number here, 3. So this says, this is Bill, a new value, it's going to be 3 times. This is Jane, this is going to be repeated 3 times, right? Sarah and Alice are repeated once. You can also do this with the client, right? This first one's repeated twice and the second one's repeated twice, so on. Now, if we look at this bit of data, everything without a red number to it is actually redundant, right? Because in this name column, the second Bill, I know that's going to be Bill because I've said that Bill is repeated 3 times. So if we remove this, this still shows the exact amount of information. We can infer what they look like, but without having to have the information actually saved. So that's what it does. It simply removes this, and it stores it in a kind of much nicer way like this. So this is a much more compressed format. And so we've got rid of a lot of rows, which means we've compressed this and optimized the storage. Now let's have a look at this column. Another thing we can do is we can actually say, okay, there's a lot of letters here, right? And if you think every character is going to take up space because we have to store. So I've counted, there's 137 total characters in these 5 rows here. That's all the letters that make up all of this. What we can do, we still have some repeated values, right? We can see the top and the last column are the same, the second and the fourth column are the same. So if I just say, let's just take a distinct list, a unique list, and just say all of the different values once, and then give it a key, just 1, 2, 3. And I can actually replace the values in my column with this key. So you can see this top value, Lutigen, and this bottom value are the same, and this is number 1. I replace this with a 1, and the Cronin is a 2, and I replace the Cronin with a 2. And now, this still says the same information because I can look up the 1 and see what it actually references in my top table. But in this time, I've actually reduced it from 137 to 84. It's quite a big reduction in number of characters. And if you can imagine, this is only 5 rows, but when you have millions and millions, this is a huge amount of storage. So let's have a look. What actually happens going from our table throughout the end is, firstly, we split this down, we remove the unnecessary, we add a bit of information, just say how many times it's repeated. Then, for both columns, right, we do the same thing. We add a lookup table and remove all the letters, so it makes it a lot more efficient. And then as it's stored, column storage, just like we did before, we put it all in a line and column storage. And we can see just how, this is quite much smaller, very optimal, and we've really optimized how this column storage is done.